Hi everybody, I'm Kathleen and we're going to be talking a lot about conductivity and circuits this week. So the labs that we're going to look at today are on parallel circuits, series circuits, a combination of both. We're also going to be looking at different types of, you guessed it, Plato, seeing whether a conductive Plato or a non-conductive Plato makes a difference in a circuit. So stay tuned for some fun with circuits. Okay, so we're doing some Play-Doh labs here. I look like I'm talking here. I'm on most of these videos I was talking, just kind of trying to narrate how I was doing this, but I did shoot this video before I submitted my first lab. As you know, I wasn't able to show you the proper angle really, but as we move along in these videos, I was able to get a tripod and showcase how the Play-Doh was being made and how the circuits were working. So here I used some blue food coloring and I was making the conductive Play-Doh. So I made this a total of 2 times, as you know, just trying to see if when I made it impacted if it was conductive or not. And I followed the same recipe for both of these, putting in the ingredients that would make it truly conductive, scraping the bowl, etc. in this video, just trying to get that there. But unfortunately, my circuits, as we know in the long run, didn't really work out the best, but here I am putting it in a pot. And so it's important to know that the mixture created with the salt and flour was a mixture, but then putting ingredients together and mixing them in this lab made something completely different, and that was a new substance forming because chemical reactions were occurring once I put this on the stove. So my mom obviously followed me over here with the camera trying to get a good angle of me mixing it on the stove, and the new substance was forming here, and because it got hotter, and when you add water and flour, there's a long chain-like molecule of the flour that creates the proteins needed to stick together. So you can see me stirring this, and then here I am mixing it with the extra flour, just trying to make sure, because I was supposed to add a certain amount of flour once it was hot. So I let it cool, and then I mixed the flour into it. And it's important to note that the salt helps the process by letting the proteins stick together more strongly, and also keeps the Play-Doh from going bad. So this blue Play-Doh I made actually is still good to this day, and I made this a few weeks ago before I went on vacation. And it's also important to remember that oil coats the other ingredients and helps keep the Play-Doh from getting like way too dried out or anything like that. I noticed if I kept it out for long enough, it would get dried out eventually, but keeping it in a container really helped. So here I am just kind of mixing it, and it did not smell the best if I'm being honest, but I mixed it just to get the texture I wanted. So I had to keep mixing it till it wasn't sticky anymore. And it was really interesting to see, there's how it turned out in the end. I finally got my tripod. You can kind of see it in this. But it was just like regular Play-Doh. And then here's the yellow version I made when I redid the circuits, because as we know, just a note on my circuits, they were not working. As I met with you, you know this. We made sure the wire was sanded down or stripped properly, made sure that the Play-Doh was right as I remade it here. I didn't really have any issues with my non-conductive Play-Doh, as you'll see that I make later. That's purple, but also that wasn't supposed to work anyway. So that's just a note on my circuits. I tried everything. I think the LEDs might have been bum. I don't know. We could only find a few somewhere, so we weren't really in the market to get a lot of LEDs just because they were really hard to find where I'm from, which was really weird. But yeah, so there's the yellow Play-Doh. I remade it because I wasn't sure if the Play-Doh would make a difference in the circuits, if it was newer or older, but as we mentioned, that the oil coated it and kept it from getting dried out with the blue, so it really didn't make a difference. But that's kind of my own little side experiment, trying to troubleshoot what was wrong with my circuits, although we never really did find out what was wrong with my circuits. But, I got to make some Play-Doh, and that was really fun. So yeah, there's my yellow Play-Doh, giving you a better angle of just me mixing it in, getting that just right. The second go around, it was a lot easier because I knew what to do. But it didn't smell any better and kind of looked like mashed potatoes. But there's my second round. And adding a little more flour because I wanted it to, it's really important not to have a sticky texture. And adding the flour also holds the water in place and keeps the Play-Doh together. So that's really important for the scientific reason behind the structure of the Play-Doh. So molecules from the food dye also spread out throughout this dough, giving it the yellow color. So now we're on to the non-conductive Play-Doh, which was pretty similar, but I didn't cook it on the stove. I used some different ingredients. Basically, I didn't use the lemon juice or the salt or any of the conductive ingredients in here. So this one kind of just smelled like dough I would use to make cookies or something. It was very basic. And I noticed that like the oil and the food coloring had kind of a different reaction with this. Maybe it's because I used purple and it was darker, but this was definitely a different texture than the last one I made. So I was able to get a good angle, thankfully, on this. And it was really interesting because I didn't have to cook this form of Play-Doh on the stove, but it was really the same consistency, it seemed like. And this is actually the second time I made it too, because first time I made it, I didn't add enough flour. And after talking to you, thankfully, I learned that was what I was supposed to do, because I think I added too much water or something happened with the distilled water. But once I was able to get the correct amount and just add more flour, I was able to mix it up. And so I kind of struggled getting the food coloring evenly dispersed because the molecules were taking longer to spread out throughout the dough. I think it was also just, it wasn't as easy of a dough to work with in the long run as the conductive Play-Doh. The conductive Play-Doh reminded me a lot more of what normal Play-Doh in the store would be like, that I used when I was a kid, versus this, which was a lot, it felt denser almost, just harder to maneuver. But I was able to get the color mixed pretty thoroughly. So I was able to use both of these for my circuits, and they turned out pretty good. I was pretty impressed with my skill, and I learned a lot about mixing it. So there's the non-conductive Play-Doh, and I got the color mixed a little bit better once I added some more flour. So you can see I'm about to add a little more flour just to get it just right. Okay, so as we've discussed, my circuits had a lot of issues. We even met and tried to figure it out, but here it is with the original blue. So since I couldn't get the LEDs to turn on, we flipped them, we tried everything, we sanded them down, we used different ones, it just wasn't working. So I'm still gonna talk a little bit about circuits just so we can get the gist. So series circuits, which are what I was attempting to do, and you can see after each one I flip it, I flip the LED and just make sure it works, and it didn't, but I still attempted. So as you can see, the blue Play-Doh I'm using is the conductive, and the purple is the non-conductive. So we know the non-conductive did its job. It was just the conductive that we were having issues with, and like we discussed, it was probably just the LED. But some information about series circuits, which were the first circuits you're seeing here, is that each electrical component is connected to make just one pathway that the charge can move through the circuit. And each charge passing through the loop of the circuit will pass through the electrical component in a consecutive fashion. And charge flows through the circuit at the same rate throughout the entire circuit. So the circuit is no greater in one location than another, which is really interesting. But you can see I'm kind of following the steps within the circuit lab, just trying to figure out what's happening. There's a lot of videos of a lot of nothing really happening. It was kind of disappointing that I couldn't get it to light. But like I said, the charge flows through a circuit at the same rate throughout the entire circuit. The circuit is no greater within a series circuit at one location than another. And the actual amount of the current varies inversely with the amount of the overall resistance. So there's my first circuit, trying it out. It doesn't really work. I tried this a lot over the past few weeks. I've tried it probably 3 or 4 times, just trying to get it right. Didn't really work. But there's there should be a clear relationship between the individual resistors and the overall resistance of a collection of resistors within this series circuit. But the actual amount of current varies inversely with the amount of overall resistance. So you can see that within this. I'm trying to flip it. This is a pretty long time just because I'm trying a lot of different things. But LEDs, it's important to note, are light-emitting diodes, and they were created in 1962, the early 1960s, and kind of have advanced over time. Just some background on LEDs. So LEDs use solid-state lighting technology to produce light through solid matter by a semiconductor, and the current going through the LEDs only moves in a single direction, and light is produced when electrons interact positively with the charged holes, or with the positively charged holes. And the diagram on the lab itself shows a conductor, which is the wire or the conductive Play-Doh, power supply, which is the battery pack, the resistor, which was the non-conductive Play-Doh, and the LED. So as you can see, I did this with both the conductive and non-conductive Play-Doh. So I'm just going to talk about the parallel circuits lab next because if you notice this video, granted it is a little longer, but I wanted to show that I did indeed complete all the labs. So I'll get to a point where I can just say you can fast forward to the end clip, just because I really can't talk over all of it because it didn't really work. But just talking about, which I'm going to do later, which is the parallel circuits lab. So in a parallel circuit, each device is placed in its own separate branch, which differs from the series circuit. And the presence of the branch lines mean that there are multiple pathways that the charge can pass or can move through in the circuit. Each charge passing through the loop of the circuit will pass through the electrical components present in a single branch. When arriving at the branching location node, a charge splits at the branch point, and it'll travel to a low potential terminal. So in parallel circuits, charge divides up into separate branches, so there can be more current in one branch than the other, which is the main difference between parallel and series circuits. So so here you can see I'm using the non-conductive Play-Doh. We've transitioned to that. But currents outside of the branches is the same as the sum of currents of the individual branches. Same LED information as the last time. So you can see, if you keep watching, I tested out all of these and I still had issues. But the reason I included all the footage was so I could show you that I had completed the experiment. I really just didn't have as much I could talk about because the LEDs weren't working. And like I said, we tried to troubleshoot. We tried to see if it was something wrong with we checked the batteries in a LED that was not cut, and it worked. We checked all the batteries. I wasn't sure if, because we're using battery packs with 3 batteries instead of 2, if that was creating a difference. But as you could see, we could only find battery packs with 3 instead of 2. So that was kind of a point of, I couldn't really do anything with that. So if you want to write about now, just skip to the end of me kind of summing this up because as you can see, I had issues, but I still kept these in just so you could see that I completed the lab. So thank you. So we just learned a lot about circuits, the difference between a parallel circuit, a series circuit, how electricity moves through it, and how to make Play-Doh both conductive and non-conductive. Although my experiments didn't really work out the way I planned, I still learned a lot along the way. So thank you for sticking with me through LED malfunctions or whatever happened, and thanks.